welcome to our channel. Today we study 3 important questions in arithmetic progression for class 10. Here is the first simple question. The question is, how many 2-digit numbers are divisible by 7? So the numbers divisible by 7 are the multiples of 7. But here the condition is, we want only 2-digit numbers. How many are there? From this we can write the series, that is AP. Of course the series is the multiples of 7. Since the multiples of 7 starts with 7, 7 is a single digit number. I start the series from 14, which is a 2-digit number by question. So my AP is 14, 21, 28 till 98. Okay. From this series we can clearly know the 2-digit number, that is A in the AP is 14, and the common difference of 2 successive is 7, and nth digit is 98. We have to find the n value now here indirectly. This is an indirect question. So from this we can write A for 14, the first term of the series, and D is the common difference. We not subtract actually, but we do according to the rule, that is the 2 successive terms difference, that is 7. So nth term is 98. So an is equal to, nth term we know, or the general term, which is a plus n minus 1d, which is given as 98. Okay, we have everything in the general rule, that is a and d. You have to find nth value. So a for 14 plus n minus 1 d 7 is equal to 98. So 14, 7 of n plus 7n, 7 of minus 1 minus 7n is equal to 98. Okay. Seven of minus 1 minus 7 is equal to 98. So 14 minus 7 is 7, and 7n plus 7. 7n plus 7 is equal to 98. We got a simple equation finally. We transpose one by one to the RHS. So the final equation we got is 7n minus 7 is equal to 98. So 7n is equal to 98 plus 7. So 7n is equal to 105. So n is equal to 105 by 7, which is 13. So there are 13 number of numbers which are divisible by 7. Therefore 13 2-digit numbers are divisible by 7. Okay, 7. It's a very important question, not direct question. Find the nth term. Instead of asking finding the nth term, it is one way. They put a rule, that is 2-digit number, 3-digit number. So it's a simple question and also an important question. Now here we see the important question of 2 marks again. The question 2 is, five times of fifth term of an AP is equal to 8 times of 8th term of the same AP. But what you have to show is, show that term 13, is 0. Okay. From this question, we can define the 5 times of 5th term and also 8 times of 8th term. We can make both equal. So first, let's write the 5th term of AP. A5 is equal to A plus 4D, we know. And 8th term is A plus 7D. But the question is 5 times of this is equal to 8 times of this. Okay, I write therefore 5 times of term 5 is equal to 8 times of term 8. Okay. Term 5 already we know that is A plus 4D. Term 8 is A plus 7D. I substitute these two in the place of A5 and A8. So 5 times of term 5. So 5 times of term 5, that is A plus 4D, is equal to 8 times of 8th term, that is A plus 7D. A plus 7D. Okay, let me compute. 5A plus 5 4s are 20D, 8A plus 8 7s are 56D. If I transpose all LHS to RHS, I get 8A minus 5A plus 56D minus 20D is equal to 0, because I transpose everything which are on the LHS to RHS. There is nothing remain on the LHS. Okay, now 8A plus 5 minus 5A, 3A plus 56 minus 20 plus 36D is equal to 0. If I divide the whole equation by 3, what I get? A plus 12D is equal to 0. So what is A plus 12D? Which term it is? 13th term. We know term 13 is A plus 12D. We got its value is 0. Okay. So we showed that 5 times of 5th term, when it is equal to 8 times of 8th term, it is equal to the sum of 5 and 8. The same type of question may give different way by changing these numbers. M times of mth term and n times of nth term is equal. As previous question, 5 times of 5th term and 8 times of 8th term are equal. Instead of 5, 8, you are given here m and n. Show that m plus nth term is 0. See, in the previous example, we got the 5 plus 8th term, that is 13th term, we showed that 0. Instead of 5 and 8, here we have numbers, sorry, the variables m and n. First, let's define the nth term, that is mth term is A plus m minus 1d. Okay, the same way nth term I define is equal to A plus n minus 1d. By question, m times of this is equal to n times of this. Okay, m times of mth term, that is A plus m minus 1d, is equal to n times of nth term, that is A plus n minus 1d. Let me multiply m of A, m of n minus 1d, m minus 1d, that is plus m of m minus 1 d is equal to NA plus n of n minus 1d. N of n minus 1d. Okay. For my convenience, I write both the factors here side by side. Wherever I write m and d, the product remains same. Here also I do the same to avoid confusion or for my convenience. In my next step, I group this as MA plus MD of m minus 1. M minus 1 is equal to NA plus the same way ND of n minus 1. Okay. I transpose everything to LHS so that right side becomes 0. So MA minus NA plus MD of m minus 1 minus ND of n minus 1. Okay. Now by grouping, factorization, the first one is a pair, second one is a pair. For the first one, A is the common. So this is A of m minus n plus, here what is the common? D is the common. So D of m minus 1 minus n of n minus 1. Okay. Let me compute this in my next step here. So let me continue here. A of m minus n. So A of m minus n plus D of m square minus m square minus m minus n square plus n minus n square plus n. Let me reshuffle the 4 terms which are in the floor brackets. Let's see what happens. So A of m minus n plus D of m square minus n square minus m plus n. Okay. Again, let me group this. First group, second group. So A of m minus n plus D of m square minus n square. So that I can split further into factors as m plus n, m minus n, minus of m minus n. Okay. Okay. Now let me split this into as its factors m plus n, m minus n. So A of m minus n plus D of m plus n of m minus n minus m minus n. Okay. Now if I factorize these terms which are in the bracket, what are the common here? Here also we have a pair of, this is 1, this is, of course this is into 1 you have to imagine. So I can take m minus 1 is the common factor which are in the floor bracket. A of m minus n plus D of m minus n is the common factor. M minus n of m plus n minus 1. M plus n, sorry, minus 1 are the uncommon factors. Again we have the common factor m minus n in both. If I take m minus n is the common factor, m minus n is the common factor of, what are the uncommon factors in the first term? A, and the second term plus D of m plus n minus 1. m plus n minus 1. Okay. See here, when you transfer this everything to LHS, we remain with 0 on the LHS. Let me continue. 0 now is equal to 0, is equal to 0, of course is equal to 0, 0, 0. Now we see, here we have two factors, that is m minus 1, m minus n is 0 or the whole is 0. Okay, let me see this, m minus n is equal to 0. I take this part that is a plus, I change the position of b also at the end. M plus n minus 1 b is equal to 0. We got clearly this is m plus nth term. What is m plus nth term? Term a plus n is equal to a plus m plus n minus 1 d. But what is it? By question 0. Okay. It is a very important question. They may give letters P and Q or K and L or M and N. This derivation is very, very important. It gives some training to your mind. So practice these 3 questions for today. Thank you for watching.